Hi everyone, my name is Jeremy. I'm a professional musician, producer, and technologist. Today, I want to demonstrate a performance setup that I've been working on that uses machine learning in a live context. I'm really interested in what happens when we can leverage artificial intelligence technologies in a performance ecosystem, especially the interaction with live musicians and out-of-the-box instruments like synths and percussion instruments. The goal of this video is to make these technologies as transparent and as accessible as possible, especially for artists who are curious about incorporating these technologies in their own artistry. So while I'm going to get into some technical territory at times, if anything is unclear or if you have any questions, please feel free to leave a comment in the comment section below. I'll also be making offshoot videos that go deeper into specific topics from this project, things like custom Launchpad programming, the Max for live devices, as well as sound design and performance concepts. If any of that sounds interesting to you, please like and subscribe to stay up to date. So, without further ado, let's get into it. At the center of everything is Ableton Live. This is where the audio is routed and processed, and where the music computing devices live. I'm also using the Electron Octatrack as my instrument for sampling, sequencing, and live audio manipulation. For controlling various parameters inside Ableton, I'm using the Novation Launchpad Pro MK3. On the music computing side of things, there are two main technologies that are essential to this project. The first is FluCoMa, which is a music information retrieval and machine learning toolkit that runs in Max MSP. And the second is RAVE from the Acids team at IRCAM in Paris. I'll leave links to both the FluCoMa project and the RAVE project in the description. So for the first part of the system, I need to record, segment, and analyze audio. This is where FluCoMa comes in. So as I mentioned earlier, the FluCoMa project created a library of tools for Max MSP that we can use to analyze and manipulate audio in very creative ways. At first glance, it might look intimidating, especially if you're not a music programmer, but we're going to walk through this step by step, and by the end, you should have a clear idea of how it works. So let's get audio into FluCoMa. Don't worry, this onslaught of random samples is just for demonstrational purposes. So I'm going to use a custom page that I created on my Launchpad, where I can select how much audio I want to record between 1,000 to 5,000 milliseconds. That's 1 to 5 seconds. And when I press record, you can see a couple things have happened. First, FluCoMa has found the onsets, or transients, of the incoming audio, and created the slices here. The second thing FluCoMa has done is to analyze each of the slices and measure two characteristics of each slice: how loud it is and how bright or dark it is. These characteristics are called descriptors, which is a term music technologists use for measurable properties of sound that we often perceive intuitively. In this case, FluCoMa is using loudness and spectral centroid as the descriptors. It then places all of the slices onto a two-dimensional map, which is called a corpus, where each slice is positioned according to those two characteristics. This allows me to play back and navigate the slices in a musically intuitive way, because similar sounds are located near each other on the map. I can then move around this corpus and trigger slices using another custom control page on my Launchpad. As you can see, I do have some slices, but I can lower the threshold of FluCoMa's onset detector to give me more slices of the incoming audio. This gives me a much richer sound palette to work with. So for the next part of the system, we have RAVE. RAVE is what's called a neural audio synthesizer. And what it does is takes a whole bunch of audio files like vocals, percussion, even whale sounds, whatever really, learns the timbral characteristics of that audio, and then resynthesizes audio according to that learned timbral model. Here I'm using the plugin version of RAVE, and I've selected the ISIS vocal model. This sort of pizza pie with a tambourine in the middle represents the 8 latent spaces of the model. Think of latent spaces as the organization of a model's timbral characteristics. As I begin to raise the bias of these spaces, you'll start to hear different sonic qualities of the model. As a straight-up synthesizer, RAVE can feel kind of random and hard to control. But where RAVE really gets interesting is when you feed it audio. You see, in real time, RAVE decodes the timbral characteristics of audio that you feed it and tries to map it to the timbral characteristics of the model that you've chosen. This is called timbral transfer. Here, I have RAVE and a drum loop playing. As I start to send the drum loop to RAVE, you can hear that the model starts to change character. It's almost like RAVE is giving its interpretation of the drum loop within the confines of the vocal model. I've also created an audio effect rack for the RAVE plugin, which gives me quick access to the latent space parameters. Nested in the rack, I have another rack of LFOs that I can turn on and off, creating richer textures to explore the latent spaces. These timbral changes will become really important for the next section. So for a quick review, live audio comes into FluCoMa. FluCoMa creates a memory of my performance in this 2D corpus. Then I can feed the audio of this memory into RAVE, and then RAVE, using timbre transfer, outputs its version of the performance. Now we can complete the performance feedback loop. I'm going to feed the output of RAVE back into FluCoMa so that FluCoMa can analyze RAVE's output for MFCCs. MFCCs are another audio descriptor that describe the overall timbral characteristics of a sound. This visualizer is telling me that the MFCC analysis is running. At the same time, I am telling FluCoMa to look for the onsets of RAVE, which you can see here. Once I turn this on, at every onset, FluCoMa will take a snapshot of RAVE's timbral characteristics, shown here in this interface, and then select a slice from the 2D corpus that most closely matches that timbre. How? Well, if we go all the way back to the beginning, when I asked FluCoMa to analyze the incoming audio slices for loudness and centroid, I also asked for the MFCCs. This loop allows me to create a short timbral model of my most recent performance, use the timbre transfer to influence the other performer, which in this case is the RAVE model, and then the RAVE model reinterprets the timbral model in the 2D corpus through what is called concatenative synthesis, which I'm going to leave for another video. And anyway, the loop starts all over again. So that's the system. For me, this is where the technology starts to become really interesting for artists, not just using AI to generate content, but using it to create interaction, dialogue, and new performance possibilities. If you are an artist and you're curious about working with these kinds of systems, I hope this gave you some ideas and maybe some of these concepts feel a bit more approachable and less like a black box. In future videos, I'll go deeper into specific parts of this system, as well as exploring other performance possibilities with these technologies. But for now, I just want to say thanks for watching, and if you have any questions, please leave them below in the comments, and I'll see you in the next one.